little bit this year, but a function has a relationship between input and output values. Okay? Now remember, the input values is called the domain, and the output values is the range. Okay? For a function to be true, there's basically two things. There's two ways you can test a function. For a function to be true, it must have exactly one output for each input. Okay, for example, I'll give you two examples here. One is we have numbers 1, 2, 3, and 4, and these are our input values. Our output values are 2, 4, and 6. All right, let's say we get this right here. Okay, this is a function. Okay, each input value has one output value. Okay, now, if you have something like this, if we have the same 1, 2, 3, and 4, and now we have 5, 7, and 9. And then we have 1 goes there, 1 goes there, 2 goes there, 3 goes there, 4 goes there. Okay? This is not a function. The reason it's not a function is because of this. That one, the input of 1 has two output values, a 5 and a 7. You can't have two output values for the same input value. Now, you can have the same output value for two different inputs. Okay, so for example, the 3 and the 4 being the output of 9, that's fine. That can happen. Just like we had over here, we had 2 and 3 both had the output of 4. That's okay for a function. Okay, it's when the input has two different outputs, that's when it's not a function. It can't be a function. That would be saying, like, for example, 2 times x. Okay, and so when I plug in 1, I get 2 times 1, that would be 2. Well, that would be like me saying that it's a function. If I plug in 1 again, I say 2 times 1 and I get 4. Okay, obviously that can't happen. Okay, unless something else was done to it besides multiplying by 2. All right, so that's one way how we check to see if a set of numbers, set of input-output values is a function. The other way that we can test is called the vertical line test. Okay? Now, what the vertical line test says is this. Look at the bottom of page 256. Okay, look at the bottom of page 256. Okay, they have given you examples of functions that have been tested with the vertical line test. What the vertical line test says is this: if I can draw a vertical line and hit 2 points on whatever they've drawn, a line, a curve, anything like that, then it can't be a function. Okay, you see examples of that. For example, they have the line, or they have the V here, like that. Okay, well, if you draw a vertical line through any part of that, okay, you're not going to hit 2 points. Okay, in other words, it's going to hit 1 point there, 1 point there. Though everywhere it touches, it just hits 1 point. Okay, so that would be a function. One that is not a function is where we have this. Okay, now I can draw a vertical line. Okay, you can draw a vertical line and you hit a point on that and a point there. Okay, so since the vertical line hits 2 points, it can't be a function. Okay, and then you see the last one that they draw is an S, like that. Okay, well, obviously, I can draw a vertical line through that and hit multiple points. Huh? No, it's at any place on the line. If it hits anywhere, there's any place that you can draw a vertical line and hit 2 points, it can't be a function. So, yeah, I can't come down here and just go, okay, I'll draw a line right there. It's a function. It's not a function because I can do this right here. So, basically, if I fill the page with vertical lines like this, and I hit any 2 points on that same line, then it can't be a function. Okay, it's not like, can I pick one spot and try to, get it where it's not a function. All right, so that's the 2 ways that we know whether or not it is a function. Okay, now, let's look at function notation. Okay. Function notation is this. That is what a function notation is. This is f of x. That's how you say that. That is f of x. Okay? You will have g of x. You will have w of y. Okay? So they could list it like this. They could list it like that. Okay? Most of the time it's not going to be like that because they don't include a y there. They usually put an x most of the time. Yeah. Eventually you will get to some points where it will be a little bit different when you start getting into pre-cal. I know I did some pre-cal stuff last year with some students that it was a little bit different than that, but obviously I have to worry about pre-cal right now. But function notation means it is written, as f of x, g of x, h of x, any of those types of things. Now, what it actually looks like is this. If I have f of x is equal to 2x minus 3, okay, when x equals negative 2. Okay, so what they want you to do, is they want you to plug in negative 2, okay, into the expression. Now, so what our function notation is they want to know the f of negative 2 equals 2 times negative 2 minus 3. Okay, and what does that equal? The f of negative 2 is equal to what? What? Which is what? Negative 7. So negative 7 is your answer to that problem. He always looks that way. All right, now, we can also write this. If they tell you to graph f of x equal to negative 1/2 x plus 3. Okay, well, what that means is this. I can take this is just function form that we've talked about in the past. I can take this and just change it to y equal negative 1/2 x plus 3. Okay, where the slope then, the slope is equal to negative 1/2 and the y-intercept is equal to 3. And so if I graph that, if you graph that, then that means y-intercept is 3. So 1, 2, 3. There's my y-intercept. And now my slope is negative 1/2. That means my slope is going to go like this. Okay, and so that's negative 1/2 is the slope, which means rise over run. And the key being that it's negative. So that means I'm going to go down 1 to here. And then I'm going to go to the right 2. 1, 2. There's my next point. Then I'm going to go down 1, and I'm going to go over 1, 2. So there's your point. Okay, there's my graph. Remember, we're working on our slope triangle. Here, here, then here, and there. Okay, where this is 1 and that's 2, 1 and that's 2. And here you have a negative, here you have a positive. Here you have a negative, there you have a positive. Okay, which makes a negative slope line. Okay, now, I want to look at some actual problems now. All right, let's look at number 14. Look at number 14. Here's what I want on number 14. Okay, on 14, 15, 16, 17, 18, and 19. Okay, what? Oh, my bad. Why wouldn't I solve it? Because I don't have what x is equal to. I mean, I don't have, in other words, to be able to solve something, I have to have 2x, like in that particular one. Let me go back up here to it. Where's that? Right there. For this to be able to be solved, I can't have this over there. I have to have a number. In other words, I can't solve for x with one side of the equation being f of x. There's no way to do that. Okay? And so they have to give you something that x is equal to. What they're basically saying is you have 2x minus 3 and x is equal to 5, or 2x minus 3 and x is equal to 10. It's almost like you have this right here where it's 2x minus 3 just by itself. Okay, and without a number value associated on the other side, then I can't solve it. What we've had in previous lessons, even the last lesson, is we would have something like this. We'd have something like that. Now that I can solve. That I can change to, I can change that to slope-intercept form because I can take the 2 over, it becomes a negative 2, and then I can set it equal to 0. Once it's set equal to 0, I can set it in y-intercept form. Okay, and so that's why you can't solve this one. It's because of the f of x that they put right there at that end. And that's why you can't solve it. All right, let's go back here. All right, 14 through 19. Okay, on 14 through 19, I just want you to write yes or no for a function. Okay? I don't want you to write the domain and the range. Okay, why would I want you just to repeat the numbers that are already listed for you? I mean, the domain is the input, the range is the output. Okay, they said directions tell you to give the domain and the range. You don't have to do that. We're not going to waste time just relisting numbers that we've already listed. Okay, now, everybody look at 20 through 28. Okay, on 20 through 28, you only have to do the x equal 2 and the x equals 0 values. You don't have to do that third value. So, for example, on number 20 says f of x equals 10x plus 1. Okay, all you have to do is plug in, f of 2 equal 10 times 2 plus 1. 10 times 2 is 20 plus 1, 21. And then you plug in f of 0 equal 10 times 0 plus 1, which means that's equal to 1. So you just have 21 and 1. And then instead of plugging in negative 3 as well, you don't have to do that. Okay, so to cut a little bit of your work out for you.
So basically for 20 through 28, we're just going to do two different equations.
Yeah. All right. Look at 29, or look at 29 through 31. Look at 29 through 31, and I want to look at your different choices. Okay? I want to look at, on number 29, is that the function of A, B, or C? Is that the function of A, B, or C? Now, let's look at it. Let me show you how to make sure everybody understands how you find it. You have this right here, okay, and you have a line running through that point, and 1, 2, 3, 4, that point right there, there's your line, okay? Well, the first thing you want to do is where does it cross the y-axis? -2. So that means my y-intercept is -2. Well, the problem is two of them that have -2 is a y-intercept. So the next thing you got to do is figure your slope. Okay, your slope then, let's see if I can erase. What? What do you mean, cross to the point halfway in between those two? You have, if you look here, you got 1, 2, 3, 4. So your run is equal to 4. Your rise is equal to 1, 2. So your rise is equal to 2. And what does that equal? 1/2. So which one is it then? So that means 1/2 x. So that's what your slope-intercept form would be. Which one is that? Which one? C. Okay. C is in cat. Kumbaya. Huh? Oh, my bad. I know. I don't have to, because they didn't mark it. Still get the slope the same way. It's still going to get 1/2. Why is it easier that way? I'm sorry. I thought you could do 5th grade math. All right. Now. Yeah. Well, follow that rule some. Let's say we have this. F of x equals 4x plus 1. And they tell you to graph. They want you to graph that expression. Okay? If you're going to graph that expression, then all we have to do is take this and make it y. And that's y equal 4x plus 1. Now you have your slope. Your slope is equal to 4 over 1. Your y-intercept is equal to 1. Once again, where we get the y-intercept equal to 1 is there. Where we get the slope being 4 over 1 is there. Okay, so then you just graph it. If we graph it, okay, so your y-intercept is 1, which is right there. And your slope is 4 over 1, and it's positive. So I'm going to go up 4, 1, 2, 3, 4, and over 1. Right there. Now, going up is positive. Going to the right is positive. Then I'm going to go here, and I'm going to go 1, 2, 3, 4, and over 1. That's negative, thus equaling a positive. Okay, and so there's your line. Okay, so that's how you would graph it using f of x equal whatever I said. Yes, Ella. The point right there, yes.
And so the one on the top is the slope, or?
No, the one how I got the one at the top is using the slope, going up 4 right here and going over 1. So that right there is 4 units, and that is 1 unit. And it was a positive 4 and a positive 1. How I got the bottom point is I went down 4 units and over 1 unit. And so that is a -4 and a -1. And the two negatives make a positive, and so that's, if you take -4 over -1, that equals that slope. And if you take a +4 over a +1, that equals that slope. And so I started with the y-intercept and then went to the slope after that. Matt? Yes. Just to make sure that you get your line proper. All right. No. Next one. Last one. Finding the slope find the slope of f of 2 equal -3 and f of -2 equal 5. Okay, now, I don't think they give any example. No. Now, here's what you have. A while ago, f of x is this. If I look at an ordered pair, it's x and f of x instead of y. Instead of x and y, the y is represented by the f of x. Okay, so having said that, then, this is my y. This is my y2. So remember, our slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so I'm going to plug in. So this is x1, this is x2. So I'm going to plug them in. So that gives me -2 minus 2 over 5 minus -3. Whoops, seen here. Nope. Why is that? Yeah, okay, hang on. I wrote that wrong. Let's look at it again. I wrote this wrong. Okay, let's look at this first one. All right. This right here is the same thing as y equal -3. Okay? This value here represents x. Okay? The value in the parentheses, as we go back up here, and I can show you, right? Back up here, right here. Okay? This right here represented the x. Okay? So the f of figure that we had in this problem, and this is how it always is, the f of 2 here means that x is equal to 2 and y is equal to negative 3. So our ordered pair is 2 and negative 3. So the other one, f negative 2, so f negative 2 is equal to 5. Okay, that means that the x is equal to negative 2 and the y is equal to 5. So it's negative 2 and 5 is your ordered pair there. Okay, so the only thing that changes from this is I just need to reverse it. 5 minus negative 3 over negative 2 minus 2. And so that gets you 8 over negative 4, which is negative 2. So the slope is negative 2. Now let's look at another one like that real quick. Let's say this: f of 9 equal 1, and actually negative 1. F of 9 equal negative 1, and f of negative 1 equal 2. I'm fixing to show you again. Okay, this is the x value, so that's 9. This is the y value, that's negative 1. So there's your coordinates. This is your x, negative 1. This is your y, positive 2. Okay? Now I just plug those into my slope, and we'll say this is x1, y1, x2, y2. So that's 2 minus negative 1 on top. On bottom, we have negative 1 minus 9. Okay, and so on top we have 3, and bottom we have negative 10, which is negative 3 over 10. And for some odd reason, which they don't ever really do this, but they've expressed it in the book as this, which I don't care. I prefer you to express it as a fraction because we don't really ever express slope as a decimal or mixed number. Okay? All right. So your homework. Yes, Brianna.
So the first one we get is like F9 equals negative 1.
Yep.
X1 is Y1.
Right. And I could have changed the first one to x2, y2. It doesn't matter just as long as you keep the two straight in your slope formula. 4.8, 11 through 52 even. 11 through 52 even. Because I want y'all to always ask me that question. 11 through 52 even.